Hello and welcome. This is Chapter 3, Section 3, Part B of our logarithms properties. Our main focus will be condensing these logarithms back into a single logarithm and applying the change of base formula. Just to remind you, here are the three properties we talked about yesterday in Part A. Just remember our base, which is A, has to be not equal to 1, and it has to be bigger than 0. So those are a few things just as a reminder as we're going through, because a logarithm can't have a base of 1, nor can it be a negative base. So we're going to start condensing these into a single logarithm. We kind of did some of that yesterday in a few of those first problems, but today we're going to focus mainly on that, and that's using both the product and power rule and the quotient rule. And usually what I do is I always go kind of with the power rule and then I do product and quotient. Versus the other way, I usually do product, quotient, and then I do the power rule. It's kind of like an order of operations. So in this case, if I have something in front of these, I can bring that up in front or back up into the power. I could also do that here and put that back up here, but I might just condense this first, or actually, because it's in parentheses, I'm going to bring this has to go both to the z and to the x. So that will actually go to both because of that set of parentheses. So let's use that power rule, but doing it backwards. So when we do this, this is the log base 3 of w squared, plus we have in parentheses the log base 3 of now z to the third, and then minus 2 log base 3 of x to the third in that parentheses. We can also, now that 2 is in front, we can bring it back up into this and actually get that to become a 6 there. So let's do that. So if we think about this, this is good. This is log base 3 of w squared plus, and let's just distribute this plus sign out, basically getting that to become the log base 3 of z to the third, and then this is now minus log base 3 of x to the 3 times 2, or x to the 6th. So now we have all of this, which now we have the product rule. We're going to multiply these two and put it into a single logarithm, and then this one's the division, so it'll be on the denominator. So how this works, it has to be a single logarithm at the end. So we're just going to write one log base 3 of a bunch of things. So we have division because there's a subtraction. So whatever is divided by will be whatever is minusing. So we just have to write the x to the 6th because we're condensing it to a single logarithm. We do not need the log of 3 anymore. We just need the x to the 6th. So the only things that we are going to be focusing on or this x to the 6th, which will be on the bottom, and then we're looking at this, and that should be what's up on top, and we're multiplying those. So this should be w to the 2nd, and then timesing by z to the 3rd. And this will be my final answer as a single condensed logarithm. Again, it will be just one logarithm with a base of a bunch of things put together in multiplying and division with exponents. So let's try one more example together. So again, we're going to use that power rule. We're going to bring that up. We're going to bring that up, and then we're going to bring that up. So in this case, we have the log base a of y to the 7th minus the log base a of z to the 1/4, and then plus the log base a of x squared. Again, you can put these all in parentheses. It is something I kind of like to do, but you don't have to unless there are more than one thing, or if you have addition or subtraction inside of that. So now what we can do is, now that we have that, the first thing I like to look at is this and rewrite that as a fourth root. So when I do that, this is the log base a of y to the 7th minus the log base a of the 4th root of z, and then plus the log base a of x squared. Again, those are all in parentheses. And then we can finally condense it to one single logarithm. So again, we're going to take the log base a as our final thing, log base a, and then we have a whole parenthesis set. Because there is, in fact, subtraction, there will be a division here, and if there's a plus sign, there will be multiplication. So we will have something like this. Again, what is on the bottom is what is subtracted. So whatever is subtracted, this will be on your denominator, and whatever is positive, because that's positive, this is also positive here, those will be on the top, which is your numerator. So we will write that, I'll put all that stuff up here. So let's write that at the bottom. Because it's again negative, we'll have that fourth root of z, and on the top we'll just have that y to the 7th times x squared, and that will be my final answer as a single logarithm. So again, this will be my final answer here. One logarithm, log base a, nothing else, no other logs inside of it. A common mistake is to put the log on top and bottom as well, but that is not needed or necessary or accurate as well. So here's an example for you to try. See if you can do it. I will have an answer shortly, so pause it, try it yourself. So hopefully you got y to the 4th, z to the 2nd, w to the 8th inside of the log base b. Again, this 4 will go to both of those. And then this negative, or this 2 will go up into the power, so it'll be 4 times 2, so that'll be the 8th. That's why, and it's a negative, so it goes underneath. So our last thing today will be adding a fourth property, which we already did the other two, as this fourth one, which is the change of base formula. It allows us to take and change the base of the logarithm, and we usually change it to either the natural log of x or just the log of x. So we usually use a base e, change it to base e or to base 10, because that's what we have on our calculator. So if we're thinking about bases 2, 3, 4, 5, whatever else, that's not a e or a 10. Those are not on our calculator, so we usually end up changing it to that. And this formula just says the log base a of x can be changed into the new base, whatever base you choose. So we're going to take the log of x over the log of a with that new base. So let's do a quick example here. So if we have the log base of 1 over 4 of 1 over 3, I'll put that in here, we can rewrite this as either a new logarithm base 10 over another logarithm of base 10, which whatever is on the inside of the logarithm will go up and top here, and whatever is the base will be on the bottom. So that's what we do. So we just write those in. So this will be the log of 1/3 divided by the log of 1/4. Type that into my calculator and approximate it to the nearest thousandth, which if we do that, we get 0.793. This is changing it to the log base 10. This also is equal to the natural log of 1/3 over the natural log of 1/4. It doesn't matter what it is as a base. Either one of these will work, and if you just check it on your calculator, it is exactly the same thing. So as our last thing, we're going to be using that change of base formula and some of the other properties to solve an equation. So if I have the log base 6 of 7 to the x minus 3 power, and that is equal to 13, I can first take this and bring it down in front. So now I have x minus 3, and I have to put that in parentheses of the log base 6 of 7, which is in fact still equal to 13. Now, what we can do is we can divide both sides by that log base 6 of 7, and then we have this x minus 3 still here, which is equal to 13 over, well, we can rewrite this all as the log of 7 over the log of 6 using that change of base formula. Again, we can do the log of 7 over the log of 6. We're just changing the base from 6 to log of 10, or log base 10. And then once we do that, let's move that all up. We just have to add that 3 to both sides. So x is equal to 3 plus this 13 all divided by this log of 7 over that log of 6. Now we just type all of that into our calculator in one go, and we should get about 14.970. That should be our answer, and you can always double check your answer by plugging this number back into the original exponent and seeing if it works. So that is one thing you can check. So please go ahead and try this on your own and see what you can get. Pause it, I will have an answer shortly. So hopefully you tried it. You should get this as an exact answer, or you type in your calculator, you should get about 1.217.